Welcome to this video on solving simultaneous equations algebraically. So this PDF with all the questions, clues and also solutions is available at mathsupgrade.co.uk. The first set of questions on here are non-calculated questions. The first one is a 3-mark question. So we're given a pair of equations here. So we've got two unknowns, so we need two equations to solve this. What I'm going to do here, I'm going to look for coefficients of either x or y which have got the same value. So here the coefficients of x have got the same value. They're both 3 and they're both positive, so they're both the same sign. Because they're both the same sign, I'm going to subtract these two equations. Now it doesn't matter how you subtract them, you can either do the top one, subtract the bottom, or the bottom one, subtract the top. That doesn't make a difference. So I'm just going to do the top one, subtract the bottom one. So 3x subtract 3x gives me 0x. So there's nothing here in terms of x. There's no x's left. That's why I'm subtracting them. So 1y subtract negative 4y. So 1y subtract negative 4y gives me 5y. Think of 1 subtract negative 4. That's the same as 1 add 4. That's 5. So 5y equals, and then negative 4 subtract 6. Negative 4 take away 6 is negative 10. So 5y equals negative 10. Next, I'm going to divide both sides by 5, since y is being multiplied by 5, and that's an inverse operation. That gives me y equals negative 2. Now what I'll do now, to find the value of x, I'll substitute this value of y into any equation I want to here. You can pick any equation you want, it doesn't make a difference. I'm picking the top one, just because it looks easier since I don't have a coefficient of y. So 3x plus y equals negative 4. Since y is negative 2, 3x minus 2 equals negative 4. Now I just need to solve this, so I'm going to add 2 to both sides, since that's the inverse of subtract 2. That gives me 3x equals negative 2. Now since x is being multiplied by 3, I'm going to do the inverse, which is divide by 3. So divide 3 on both sides. That gives me x equals negative 2/3, or negative 0.6 recurring. That question was 3 marks. In question 2, I need to solve these simultaneous equations. So at the moment, none of the coefficients of x nor the coefficients of y have got the same value. I've got different numbers in front of the x here. I've got 4 and 1. I've got different numbers in front of the y. I've got 1 and negative 5. So I'm going to manipulate either one or both these equations to get the coefficients the same. I'm going to choose x, and I'm going to multiply this bottom equation here by 4. Times it by 4 since I've got 4x on the top. So all of this times by 4 gives me 4x minus 20y equals 52. Now I'm just going to write that top equation underneath it. Okay, and when writing underneath it, you can see the coefficients of x are the same value. They've got the same sign, so I'm going to subtract these two equations from one another. Again, it doesn't matter how you subtract them. You can do the top one, subtract the bottom, or bottom, subtract the top. It doesn't matter as long as you're consistent with both sides of the equation. So I'm just going to do the top, subtract the bottom. 4x take away 4x is 0x. Negative 20 take away 1y is negative 21y. And then 52 take away 10 is 42. So negative 21y equals 42. So I'm going to divide both sides by negative 21. Negative 21y divided by negative 21 is just y. And 42 divided by negative 21 is negative 2. Now I'm going to substitute this value into that top equation there. So when I sub it into the top equation, I'll get 4x plus y equals 10. So 4x minus 2 equals 10. I'm going to add 2 to both sides. That gives me 4x equals 12. If I divide both sides of the equation by 4, I'll get x equals 3. So y equals negative 2 and x equals 3. And that was 3 marks for that question. In question 3, I'm given these equations here, and the first thing I notice is that neither x nor y have the same coefficient. So again, I need to manipulate these equations to make sure they've got the same coefficient. for either x or the y. I'm choosing x. I'm just going to multiply this bottom equation by 4. That would give me 4x minus 12y equals 64. I'll write this top equation underneath it so I can compare them, and I can see that the x's have got the same coefficient, and importantly they've got the same sign. If they've got the same sign, I'm going to subtract to eliminate the x. So subtract and I end up with no x here. Negative 12y subtract 1y is negative 13y. 64 subtract 25 is 39. Now what I'm going to do, I'm just going to divide by negative 13, since y has been multiplied by negative 13, and it's the inverse operation. Divide on both sides, that gives me y equals negative 3. Substitute that into any equation I prefer here. I'm choosing the top one since it looks easier for y. So 4x plus y, so 4x minus 3 equals 25. Add 3 to both sides since that's the inverse of subtract 3. That gives me 4x equals 28. X is being multiplied by 4, so I'm going to divide by 4 on both sides. That gives me x equals 7. X equals 7, y equals negative 3, 3 marks. Question 4. I've got two simultaneous equations here, and I notice that none of the coefficients are the same, so I need to manipulate either one or both equations. I'm just going to choose the y here in this bottom equation. I'm going to try and get it so it's got 3 in front of it. So I need to multiply this bottom equation by 3. That gives me 12x minus 3y equals negative 3. So the coefficients aren't the same, they've got different signs. If they've got different signs, I need to add to eliminate the y. So when I add, I'll get 14x equals 7. And then if I divide by 14 on both sides, that gives me x equals 0.5. I just need to substitute that into the top equation here. That gives me 2 times 0.5 plus 3y equals 10. 2 times 0.5 is 1, so 1 plus 3y equals 10. I subtract 1 from both sides, I'll get 3y equals 9, and then divide by 3 to get y equals 3 for 3 marks. Question 5. I need to solve these simultaneous equations. Again, the coefficients of x nor y are the same, so I need to manipulate. I'm going to choose the y here. I'm going to multiply all of this equation by 3, since that would give me negative 3y. And then I know the signs of these y's are different, so I need to add to eliminate the y's. That gives me 16x equals 24, so x would be 1.5. I need to substitute that into the top equation, or any equation really, but I'm choosing the top one. So x is 1.5, so it's 1.5 plus 3y equals 12. I subtract 1.5 from both sides, that gives me 3y equals 10.5. Divide by 3 on both sides, y equals 3.5. So x is 1.5, y is 3.5 for 3 marks. In question 6, again I can notice I don't have the same coefficient in front of the x nor in front of the y. So I need to manipulate one or both of the equations. I'm going to choose the top equation here. I'm going to multiply it by 2, so then I'd get negative 4y. So I'll get 6x minus 4y equals negative 10. I'll write that bottom equation underneath it there, and I notice that the y's have got the same coefficient and it's the same sign, so the same sign means subtract, because when I subtract I eliminate the y's. So I'll get 4x equals negative 12. Divide by 4 on both sides, I'll get x equals negative 3. And then when I sub that into the top equation, or any equation here, I'll get 3x minus 2y equals negative 5. So 3 times negative 3 minus 2y equals negative 5. So negative 9 minus 2y equals negative 5. Add 9 to both sides. So I'll get negative 2y equals 4. So then I'd get y equals negative 2. So x is negative 3, y is negative 2 for 3 marks. Question 7. A pattern is made using identical rectangular tiles. Find the total area of the pattern. So this question may not seem like a simultaneous equations question at first glance, but it actually is. So what I know is that the whole height of this pattern is 7 and the whole width of the pattern is 11. So can I find the individual lengths and widths of each tile, and therefore I can find the total area. Well, since the length and width of each tile I don't know, I'm labelling them with L and W. But what I do know then is that 2 lots of lengths and a width equals 11. So 2L plus W equals 11. And I can also say that 1 length and 1 width equals 7. So length plus width equals 7. What I can then do is I can then start to solve these simultaneous equations to find the length and width, and then I can find the area of each tile, then I can find the area of the whole pattern. So to solve these equations, I've got the same coefficient already in front of the W, and it's the same sign, so I can just subtract. So 2L minus L is 1L, W minus W is nothing, 11 minus 7 is 4, so the length is 4. Now I know the length is 4, and since the whole height here is 7, I know the width must be 3, since 7 minus 4 is 3. So length is 4, width is 3, so the area of each tile, it's a rectangle, so length times width gives us 12, and there's 4 tiles altogether, so 12 times 4, 48 centimeters squared for 4 marks. Question 8. We need to solve these simultaneous equations, 3 marks. So again, the coefficients of x nor of y are the same, so I'm just going to multiply this bottom equation here by 2 to give 4y. That gives me 18x plus 4y equals 10. I'm writing the top equation underneath it. I notice that since the coefficients are the same but the signs are different, so because the signs are different I'm going to add. So 18x plus 3x is 21x, 4y add a negative 4y is 0y, 10 add 11 is 21. Divide both sides by 21 since that's the coefficient of x, and so x equals 1. I just need to substitute this into any equation here. I'm choosing the bottom equation since it looks a bit easier. So 9 times 1 add 2y equals 5. So that means that 2y would be equal to negative 4, and so y equals negative 2. So x equals 1, y equals negative 2 for 3 marks. Question 9. I'm told that 3 teas and 2 coffees have got a total cost of £7.80. 5 teas and 4 coffees have got a total cost of £14.20. I need to work out the cost of 1 tea and the cost of 1 coffee. So this is a worded simultaneous equations question. It doesn't mention simultaneous equations, but since you've got 2 different values which you don't know, and you're given 2 different bits of information, you can form and solve 2 different equations. So here's the first equation from the first sentence. Here's the second equation from the second sentence. So since the coefficients of the t and of the c are all different, I'm just going to get one of the equations and multiply it by 2 to give me 4c. That gives me 6t plus 4c equals 1560. I'm writing the bottom equation underneath it, and then since the coefficients of c are the same, I look at the signs and the signs are the same as well, so I'm just going to subtract. By subtracting, I'll get 1t equals 140. So that's the cost of 1 cup of tea, which is in pence, so that's in pounds, £1.40. I'm going to substitute that into the top equation here. So 3 times 140 plus 2c equals 780. So 3 times 140 is 420. Add 2c equals 780. But then just subtract 420 from both sides. I'll get 2c equals 360. Then divide by 2 on both sides. I'll get c equals 180. In other words, £1.80. So the whole question there was worth 4 marks. Question 10 is 5 marks, and it involves simultaneous equations, but it involves quadratics as well. What I'm going to do here, I'm going to essentially rearrange this equation to make x the subject of it, and then substitute it into the top equation. That will then eliminate x and I can find y. Then I can use that value of y to find x afterwards. So let's rearrange this. So I'll add 2y to both sides. That gives me x equals 2y minus 3. Then when I substitute that into the top equation, this is x squared here, so multiply everything by itself. substituting into the top equation gives me 2y minus 3, 2y minus 3 plus y squared equals 18. If I expand the brackets and then I simplify and then form a quadratic by subtracting 18 from both sides, I'll get 5y squared minus 12y minus 9 equals 0. I can factorize this, so then I can find the values of y by making each bracket equal to 0. So y equals negative 3/5 and y equals 3. So I've got two values for y there. I now need to substitute each value into one of these two equations. The bottom one's the easier one, so I'm substituting both into the bottom equation one by one to find the resultant value of x. So x minus 2y equals negative 3. So x minus 2 times negative 3/5 equals negative 3. So work that out. That is 1.2. And then subtract 1.2 from both sides. X equals negative 4.2. So for y equals negative 3/5, that means y equals negative 0.6. X equals negative 4.2. This value here, y equals 3, again sub it in and you get x equals 3. So x equals 3, y equals 3. The whole question there was worth 5 marks. If you're not sure on how to do this quadratic element, especially the factorizing, then be sure to check out my video file on factorizing quadratics on this channel. Question 11 is very similar to question 10. It involves simultaneous equations but also with quadratics. So be sure to check out my video file on solving quadratics on this channel. So the first thing I notice is that this top one has got y squared and x squared. The bottom one has only got y and x. So I'm going to rearrange this bottom equation to make y the subject of the equation, and then I'm going to substitute it in here for y squared. So if I do that, then I get x squared plus 2x plus 5, 2x plus 5 equals 25. Expand the brackets, subtract 25 from both sides, and I end up with 5x squared plus 20x equals 0. Now, all of these terms here I've got a factor of 5, so I can divide everything by 5 just to make it easier. So I'll get x squared plus 4x equals 0. I can factorize this quite simply. So I'll get x brackets x plus 4 equals 0. So either x equals 0 or this bracket equals 0. That means x could be 0 or x could be equal to negative 4. Substitute each of these values in turn into any one of these equations. The bottom one's the easier one, and find the resultant value of y. So when x equals 0, y minus 2 times 0 equals 5. So y equals 5. And when x equals negative 4, y minus 2 times negative 4 is 5. So y plus 8 equals 5. So y equals negative 3. So the whole question there was worth 5 marks. Be sure to check out my files on quadratics if you're stuck on this question. Question 12 is worth 5 marks. It's a very difficult question. It's probably the hardest question in this booklet. It involves probability as well as simultaneous equations. So if you're not sure on probability, specifically tree diagrams, then be sure to check out the video clip on that topic before you attempt this question. We're told there's only R red counters and G green counters in a bag. A count is taken at random. The probability it's green is 3/7. It's put back into the bag. 2 more red counters and 3 more green counters are put in the bag. A count is taken at random again. The probability it's green this time is 6/13. Find the number of red and the number of green that were in the bag originally. So in other words, find R and G. So I'm going to set up this question here. I've just underlined the key information there, and I've drawn a tree diagram. Okay, so let's just explain this tree diagram. So initially, I've got the probability of picking green would be the number of green counters divided by the total number of counters, which is G plus R, and that equals 3/7, since I'm told that in the question. The probability of picking red would be the number of red counters divided by the total, which is G plus R. That must equal 4/7, since these two branches must add up to one whole one, since they're mutually exclusive events. there's only green and red counters in the bag, so they must add up to one whole one. These second set of branches are very important. So in the second event, I've got 3 more green counters and 2 more red counters in the bag. So the probability of picking green is now going to be G plus 3 divided by the new total, which is the green plus the red plus the 5 new counters. That equals 6 over 13, since that's what I'm told in the question. For this branch here, the number of red is now increased by 2, and the total is the same as the total on this branch, G plus R plus 5, and that must equal 7/13, since again these two branches must add up to one whole one. For the branches underneath here, similar to the branches above, exactly the same actually, so that's where they come from. What I'm going to do now is I'm going to use this information here to find an equation and make R the subject of the equation. Then I'm going to do similar with this equation here. So with this equation, first of all here, I'm told that R over G plus R equals 4/7. I'm just going to cross multiply, so I'm going to multiply both sides of this equation by 7 and by G plus R. That gives me 7R equals 4 brackets G plus R. I'm going to expand the brackets and subtract 4R from both sides, and then I'm going to divide by 3 to give me R equals 4G divided by 3. So let's park that for the moment. In this equation here, I'm going to cross multiply. So I'm going to multiply by 13 on both sides, multiply by G plus R plus 5 on both sides, and then expand the brackets, and then collect like terms. So I end up with 7G equals 6R minus 9. What I'm going to do now is going to use both these equations to get the values of G and R. I'm going to substitute this equation into this equation here. So if I substitute equation 1 into equation 2, I end up with 7G equals 6 times 4G over 3 minus 9. 7G equals 24 divided by 3, which is 8G minus 9. And then I can just solve that and I get G equals 9. If I substitute that into just this simple equation here, I get the value of R, which is 4 times 9 divided by 3, which is 12. So the number of red counters must have been 12, the number of green counters originally must have been 9. I can always check these values by applying them just into the information here and see if they're correct, and indeed they are. So that there was 5 marks, a very tough question involving multiple topics. The remaining questions are all calculator questions. The first one here, you can see that the coefficients of x nor of y are the same. So I'm just going to choose x here. I'm going to multiply all of this bottom equation by 5 to give me 5x minus 15y equals 45. I'm writing this equation underneath it and comparing the coefficients and the signs. These coefficients are the same and the signs are the same, so I'm going to subtract. That gives me negative 15 take away y, which is negative 16y, equals 24. Divide by negative 16 on both sides. That gives me y equals negative 1.5 with the calculator. Substitute that value into any of the equations. I'm choosing the bottom one since it looks simpler. So x minus 3 times negative 1.5 equals 9. Evaluate that and you get positive 4.5. Subtract 4.5 from both sides and I get x equals 4.5, and of course y is negative 1.5, 3 marks. Question 14, you need to solve these simultaneous equations. I need to manipulate the equations so that either the x's or the y's coefficients are the same. It's not easy to do that with just one equation, so I'm just going to multiply both of them by a number. I'm going to multiply the top one by 3 and the bottom one by 2, since that would give me 6x on both the equations there. Now look at the coefficients, they're the same, and look at the signs in front of them, they're the same, so I'm going to subtract. Since when I subtract, I'll eliminate the x's. So negative 12y subtract 10y is negative 22y. 57 subtract 2 is 55. Divide by negative 22 on both sides, I'll get y equals negative 2.5. Sub that into the top equation, and I get 2x minus 4y, which is 2x minus 4 times negative 2.5 equals 19. So you get 2x plus 10 is 19. Subtract 10 from both sides, and then divide by both sides by 2, and I get x equals 4.5, and of course y equals negative 2.5. 4 marks. Question 15. Solve the simultaneous equations. Similar with question 14, I cannot easily just get one equation and manipulate it. I need to manipulate both equations. So I'm going to choose here y. So I'm going to multiply the top equation by 5 and the bottom equation by 6. That gives me 20x plus 30y equals 25, and 42x plus 30y equals negative 63. What I do then is I just subtract, since the signs here are the same. When I subtract, I'll get negative 22x equals 88, so x must be equal to negative 4. If I substitute that into the top equation, I'll get 4x plus 6y equals 5, 4 times negative 4 plus 6y equals 5, so negative 16 plus 6y equals 5. Add 16 to both sides, and then divide by 6, and I get y equals 3.5, and of course x equals negative 4 for 4 marks. Question 16. Solve algebraically the simultaneous equations. So I've got two equations here. You can notice the first equation, the top one here, has got an x squared and a y squared term in it. This gives us a clue that this will result in a quadratic later on. So if you're not sure on how to solve quadratics, be sure to check out my video on solving quadratics on this channel. What I'm going to do first of all, I'm going to rearrange this simpler equation, this linear equation, so that y is the subject of it. That gives me y equals 3x plus 13. So that means y squared must be 3x plus 13 all squared. I'm going to substitute that into the top equation. That then gives me x squared plus 3x plus 13, 3x plus 13 equals 25. Expand the brackets, simplify, and I'm just going to divide by a factor of 2, since every term here has got an even coefficient. That gives me 5x squared plus 13x plus 72. That makes it easier to factorize in the next step. Since the product of two brackets equals 0, each bracket must equal 0. So I'll get x equals negative 4.8 and x equals negative 3. If I substitute each of these values in turn into any equation here, then I get the values of y. I'm going to choose the bottom equation since it's a simple linear equation, and I get the value of y as negative 1.4 and 4. Then I pair them up with the corresponding value of x from here, and I write that on the answer line, and that will give me 5 marks for that question. Similar to the previous questions, question 17 involves simultaneous equations combined with quadratics. So I'm going to do here, I'm going to rearrange this bottom equation to make x the subject, and substitute it into the top equation, and I'm going to solve the resultant quadratic and use those values to find the other values for the other variable. So x equals negative 2y plus 1. That means x squared must be this. If I substitute this into the top equation here, I'll get this line here. If I expand the brackets, I've got two brackets, 4y squared minus 4y plus 1. Subtract y squared equals 17. Let's just expand this bracket now. So multiply everything inside the brackets by the 2 and subtract 17 from both sides, and I get 7y squared minus 8y minus 15 equals 0. I'm going to factorize this. That gives me 7y minus 15 and y plus 1 equals 0. The product of two brackets equals 0, so either bracket can be equal to 0. 7y equals 15, which gives us y equals 15 over 7, and y plus 1 equals 0, which gives us y equals negative 1. Substitute both values in turn into the bottom simpler equation here, and I get the values of x, which will be negative 23 over 7 and x equals 3. Pair them up with the correct corresponding value of y, and there's your 5 marks for that question. So that's the end of this video. If you struggled with any of the topics in here, particularly quadratics, be sure to check out my video on solving quadratics on this channel.